Okay, let's do lesson 8.1, Angles of Polygons, page 404 in your book. Well, first of all, we're talking about angles of polygons. What are we talking about? Well, we want to talk about first the concept of a diagonal. What is a diagonal? Well, a diagonal is when I take any vertex of any polygon and I draw a line to another vertex, but the vertex is not a adjacent vertex. So as long as I can draw on the interior, and this is for convex polygons, and what happens is when I draw a diagonal, I end up forming triangles. So in this example here, I've got a poorly drawn seven-sided figure, and I drew 1, 2, 3, 4 diagonals, and notice that I got 1, 2, 3, 4, 5 triangles formed by drawing the diagonals. Alright, so we're talking about angles of polygons in this lesson, so let's talk about the summation of the interior angles of a polygon. In other words, the degrees inside of that polygon. Okay, here's an example of some polygons. Okay, triangle, quadrilateral, 5-sided, 6-sided, 7-sided, 8-sided. They're poor drawings, but in each one I picked a vertex and drew diagonals in them. Now notice on a triangle there is no diagonal to be drawn, but in each one of these, when I draw the diagonals, I'm forming those triangles. 2 here, 1, 2, 3 here. Okay, so if we look at this as a chart, there's the number of sides, and then as I draw it, I counted the triangles. A single triangle as a polygon has 3 sides, but only one forms one triangle. A quadrilateral has 4 sides, but it forms 2 triangles with its diagonals, and so on. 5 and 3, 6 and 4, 7 sides, 5 triangles, 8 sides, 6 triangles. You'll notice that the sides minus 2 is always the number of triangles. Well, if I wanted to figure out the interior angles of that, well, I know that a single triangle has 180 degrees. So if I multiply the number of triangles formed in my diagonal drawings times 180, that'll tell me how many degrees are inside that polygon. And here it is. For a triangle, there are 1 triangle formed completely, so times 180 is 180 degrees. For a square or a quadrilateral, there are 2 triangles inside this diagonal drawing. So 2 triangles times 180 is 360. 5-sided figure forms 3 triangles. We get 540, and so on. And this goes on forever. What that led us to is the theory called the interior angle summation theory, 8.1 in your book. And here it is. If I'm given a convex polygon of n sides, the sum of the interior angles can be called S. Then here's the formula. The S, the capital S, is equal to 180 times number of sides minus 2. And that works for no matter what polygon you have. All right, let's look at an example of that. All right. Supposedly I'm given a simple, in example 1, I'm given a simple polygon hexagon. Now they've drawn it as a chemical symbols. I've just drawn the hexagon here. All right. And we know that the formula is the summation of the interior angles is 180 times n minus 2. Well, we know that this is a 6-sided figure, so all we have to do is substitute 6 in here. 180 times 6 minus 2 is 180 times 4, which gives us 720 degrees. So we know that because we have a 6-sided figure, there's going to be 720 degrees on the inside. Example 2. In example 2, you're given the fact that a side angle, the interior angle, is 108 degrees. Okay? So we need to know how big is the sum, find how many sides the polygon has. So we know that the summation is 108 degrees times the number of sides. Okay, well, we're going to find n. Well, let's just substitute our equation. We know that s, capital S, is equal to 180 to n minus 2. It's also equal to 108 minus n, so I'm going to replace this s with this version of s and solve that equation. So 108n equals 180 n minus 2. Multiply the 180 times n, I get 180n. 180 times negative 2 minus 360. Now I'm going to subtract 180 from both sides, 180n, excuse me. That leaves me with negative 360 on this side and a negative 72 on this side. I then divide by negative 72 both sides of the equation. I'm left with n is equal to 5. So there are five-sided figures when I know from example 2. And now let's look at example 3. Example 3 is a little trickier. They've given us a drawing that looks like this. They say, given this drawing, explain to me or show to me how big x and 2x are, each of these interior angles. So not only do we know the sum of them, but we also have to figure out what each size of each one is. Well, we know our summation problem is 180 times n minus 2. And we know there's 4 sides. So 4 minus 2 is 2. We know there's 360 total degrees in this problem. Okay, well, if we know that's 360 total, we can just say 360 is equal to 2x plus 2x plus x plus x. I'm just adding the 4 interior angles because I know they should add up to 360. And I look at that and I say 360 is equal to 6x. I divide both sides by 6, and I get my final answer of 60 is equal to x. However, they asked me for what are each side, so the measure of angle A and the measure of angle D, A and D, are equal to x, which is 60, and the measure of angle B and angle C, up here, B and C, is 2x, which is 120. All right, now let's look at exterior angles. We've looked at interior angles so far, so now let's look at exterior angles, the degrees outside a polygon. Now, there's one thing is you got to understand what an exterior angle is. So let's first go through what an exterior angle is. Okay, and an exterior angle, an exterior angle is, in this drawing right here, is the x. So I take each vertex, and I'm going around in a clockwise order. I can go in either order, but I go to each vertex, and I draw one extended side out. Okay? And I just draw the side out, and I make sure I do it on all the vertexes, go in the same direction. The exterior angle is this x value. Okay? So this is an exterior angle, this is an exterior angle, this. Okay? Y, I just draw y as y is the interior angle associated with that. So you'll notice that x plus y is always going to be 180 degrees. So now we're talking about the sum of the x's going around. What are they going to be? Well, let's take a look at it. If I had the number of sides, and I'm going to call it n, the sum of the exterior angles is capital N. Number of sides times 180. 180 is x plus y. So if I went around the number of sides and did that, I would get 180 times all the number of sides. And I know that the interior angles, all the y's added together, is 180 minus the number of sides, or times the number of sides minus 2. We just did that with the interior angles theory a second ago. So what happens here is I have, if I replace number of sides with n, small n, number of sides with small n, I end up with this equation, 180n minus 180 times n minus 2. Well, I multiply that out, I get 180n minus 180n plus 360. Well, 180n minus 180n is always 0. So my answer is 360. So the sum of my exterior angles is always 360. It doesn't matter how many sides I have. It's always going to be 360 degrees. Let's use that in a problem. Oh, by the way, that is problem 42 in your book. That is the proof right there of problem 42 in your book. What happens is the exterior sum theorem then becomes very simple. If you have a convex polygon, the sum of the exterior angles, one exterior angle at each vertex, so there's your qualifications, is always 360 degrees. All right, let's look at an example. Here in this example, we're given this complex drawing here. It's an 8-sided figure, and my drawing isn't perfect, but you can see that each of the interior angles are exactly the same, and I've drawn the exterior angles coming out, going around, and each of those are exactly the same. So this is a regular octagon. All right, so we know that. So since we know that, we can say, and then it asks us to find the exterior angle sum and the exterior angle degrees. In other words, what is the degrees of each one of these double-lined angles? Well, the sum, we know right off the bat, is always 360. It's always 360. And we have 8 of these things, so we can say 8 times x is equal to 360, divide by 8, and I know that each exterior angle is 45 degrees. And then it goes on to ask, well, if the exterior angle is 45 degrees, what is the interior angle? Well, we know that the interior angles are just the other half of the linear pair, or flat line, and so the interior angle is 180 minus 45, which is what our exterior angle was, and that leaves us with 135 degrees. So we now know that all of the interior angles are 135, the exterior angles are 45.